Okay, in this video we're going to talk about equivalent fractions, what they are, how do we find them, and then also how we reduce fractions or simplify fractions. Okay, and before we even talk about equivalent fractions, I just want to touch on a little bit of terminology, refresh on a little bit of terminology. These two terms we're going to talk about, one is a multiple and the other is a factor. Okay, let's use the number 12 as an example. The multiples of 12 are all my 12 times tables, right? Or all the numbers I hit when I count by 12s. 12, 24, 36, 48, 60, and on and on and on, right? We keep adding 12 every time. These are the multiples of 12. Now the factors of 12 are a little different. Those are the numbers that I can multiply together to get 12. Or on the flip side, right, the numbers that I can divide 12 by. So what are the ways I can multiply to get 12? Well, 1 and 12, right? 1 times 12. I can do 2 times 6, or I can do 3 times 4. So 12 has 6 factors. 1, 2, 3, 4, 6, and 12. Okay, so this is some key terminology to keep in mind as we go forward. Okay, we're going to start with the example of 1/2. I'll go ahead and represent this visually. Here's my 1 whole. It's broken into 2 equal parts, and of those we have 1. Okay, so here's 1/2. Now, what would happen if I drew a line right here? Did I change the value? Did I change how much I have shaded in? No, right? But if we hadn't already said this was 1/2, and I showed this to you and said, well, what fraction does this represent? You might look at it and say, all right, it has 4 equal parts, and of those, 2 are shaded in, right? So it's 2/4. Well, 1/2 and 2/4 are equivalent fractions because they have the same value, okay? Now, I kind of showed you visually what that looks like, but what actually did we do to the numbers? Well, the 1 turned into a 2, and a 2 turned into a 4. We did the same thing to both the 1 and the 2, right? Could it be addition? Well, 1 plus 1 is 2, but 2 plus 1 doesn't get me 4. What about multiplication? 1 times 2 gets me 2, and 2 times 2 gets me 4, right? So as far as if I need to find equivalent fractions of 1/2, what do I actually do? Well, I can multiply the numerator and the denominator by the same thing. In this case, we multiplied by 2. But we don't have to multiply by 2, right? Like, what have I done now? I've now broken our whole into 8 pieces, which means we have 8 pieces, and we have 4 of them. Well, what have I multiplied my numerator and my denominator by now? By 4, right? 2 times 4, 1 times 4. Okay? And what do these denominators have in common? Well, these are all multiples of 2. If I think about my multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? We can keep going, but let's stop there, okay? If you think about our multiples of 2, and let's say I want an equivalent fraction of 1/2 that has a denominator of 18, okay? Well, what do I need to multiply 2 by to get to 18? 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Times 9. So I just do the same thing to the numerator. So 1/2 is equivalent to 9/18. Okay, let's quickly try to find equivalent fractions for a different example, and then we'll move on to reducing fractions. Okay, so now we're going to take a look at a different example, 5/7, and think about what are some equivalent fractions that we could find of this, and how do we go about that process. So over here you'll see I've written out some of the 7 times tables, or the multiples of 7. So any of these multiples of 7 could go in here and become our new denominator for an equivalent fraction. let's pick a few of them and just go through the process. Let's start with 28, okay? We want to find an equivalent fraction. Well, how many times do I have to count by 7? Or what do I need to multiply 7 by to get to 28? 4. So I'll do the same thing to the numerator. 5 times 4 gets me 20. Okay, so 5/7, 20 28ths. That's an equivalent fraction. We could try another one. Let's do 84. Well, 84, that's 7 times 12. So I need to do 5 times 12 as well. Gets me 60. Okay, you're probably seeing here, we rely pretty heavily on having a solid understanding of our times tables when we're doing this, right? The more comfortable you are with our times tables, the easier that it's going to be. Okay, so now we're going to transition over to talk about reducing fractions or simplifying fractions, okay? Because when we do math, when we're going to get into adding and subtracting, multiplying, dividing with fractions, we always want to simplify or reduce our fractions down to their simplest form. And what that means is that the only factor that is shared between my numerator and my denominator is the number 1, okay? So that word factor is coming back again, all right? And if you're not positive on what I meant when I said it just now, that's fine, because we're going to talk about it a lot. So in order to reduce this fraction, we need to think about the factors of 15 and the factors of 20. So what are all the ways I could multiply to get 15? 1 times 15 and 3 times 5. Okay, what about to get to 20? I can do, well, 1 times 20. I could do 2 times 10, or I could do 4 times 5. Okay, so what we're looking for is a common factor, meaning a factor that they both have. 1 doesn't count, right? Because every number has 1 as a factor. We're looking for a different one. Okay, in this case, 5 is going to be the common factor. So what we're going to do is basically we could think, I'll show you a couple different ways we could think about this. We're going to, instead of when we were finding equivalent fractions, we multiplied the numerator and the denominator by the same thing. Here we'll divide the numerator and the denominator by the same thing. And what we're going to divide by is that common factor, that factor that they share, which is 5. 15 divided by 5, 20 divided by 5. And what's nice is if I have this times table fact in my head, I already have the answer to my division. Right? 15 divided by 5 is 3. Okay? And then here, 20 divided by 5 is 4. Okay, I want to show you this another way as well. We could think about it like this instead, okay? We have 15 20ths. We identify 5 as the common factor. I'm going to rewrite the 15 as 3 times 5. And I'll rewrite the 20 as 4 times 5, okay? And then this here, we think of as 5 divided by 5, which is 1. And we can just cross it off because multiplying by 1 doesn't change anything, right? So when we have fractions, if everything's being multiplied, we see the same number in the numerator and the denominator like this, we can cancel them out. Okay, that's another way to think about it. You can think about it like this, or you can think about it like this, whatever makes the most sense for you. So let's try another example. 14 over 21. Well, what are the factors of 14? We have 1 times 14 and 2 times 7. And what about for 21? 1 times 21 and 3 times 7. Do we see that common factor? 7. So let's divide by 7, divide by 7, and we get 2/3. So sometimes we're going to be asked to simplify fractions where both the numerator and the denominator are values that are larger than what we are on the times table chart, right? So even if we had the times tables down, we might not immediately look up and be able to identify what some of the factors of the numerator and the denominator are, and then it's really hard to simplify. So what we sometimes have to rely on are what we call divisibility rules. Okay, so divisibility just means that I can divide a number by another number, right? So, for instance, 20 is divisible by 10 because I can do 20 divided by 10 gets me a nice even quotient of 2, right? Essentially, all the multiples of 10 are divisible by 10. And if we look at the pattern, what's the pattern? 10, 20, 30, 40, on and on. They all end in 0, okay? So anytime that you see a number end in 0, you know that it has 10 as a factor, right? So potentially we could divide by 10 to simplify if both the numerator and the denominator end in 0. So let's look at an example of that. We have 180 over 240, right? Already, these numbers are larger than what's on the times table chart. But because we know our divisibility rule, right, hey, these numbers both end in 0, which means they both have 10 as a factor. I'll show it out, okay? This is 18 times 10, and this is 24 times 10. And just like in the previous example, when I have a 10 and a 10 on top of one another, this is 10 divided by 10, which is 1, so I just cancel it out, okay? Once we get more comfortable, we can also be a little more efficient and just say, hey, I'm going to cross off these zeros. And now it's 18 over 24. And if I have my 6 times tables in my head, I know these are both 6 times tables, right? So I'll divide by 6. 18 divided by 6 gives me 3, and 24 divided by 6 gives me 4. Okay, so 180 over 240 simplifies down to 3/4, or reduces down to 3/4. Okay, so now let's take a look at the divisibility rule for 2. Again, these are all the multiples of 2, which we just call even numbers. All right, and the pattern is they're going to end in 0, 2, 4, 6, or 8. And sometimes we're in a situation, maybe like this one, where I don't see anything else that might work. But I do notice that, hey, these are both even numbers. They both end in a 0, 2, 4, 6, or an 8, which means they have 2 as a factor. So I'm going to go ahead and divide by 2. Divide by 2, okay? If I'm comfortable cutting these in half in my head, half of 40 is 20, and half of 2 is 1, so 21. And then here, well, you know, there's a couple ways I could think about it in my head, but also we could do it out really quickly. 2 goes into 9 4 times. So we get 21/49, right? We divided it by 2, and now we've reduced it down. Now, hopefully I can recognize these are my 7 times tables. So I can divide them both by 7. And this gives me 3/7. Okay? So notice how we were able to use the divisibility rule for 2 here to not get stuck. Okay, so now we're going to take a look at the divisibility rule for 5, which is, again, how do I know if a number like this has 5 as a factor? Because if they both have 5 as a factor, I can divide by 5, reduce my fraction down. Okay, if we count by 5s, 5, 10, 15, 20, 25, 30, they all end in either a 0 or a 5. So if I'm asked to reduce this fraction, I could notice, hey, this is a 5, this is a 0. So they're both divisible by 5. Let's divide by 5. How could I figure out what do I get? Well, let's divide. Let's do some long division. Can never get enough practice. 5 goes into 11 2 times. 1 left over, bring down the 5. Into 15 3 times. Okay, nothing left over, so 23. And then I don't have to do the long division out for 300. Why? What's 30 divided by 5? 6. So 300 divided by 5, 60. Okay, and then from here, this is actually completely simplified. Okay, the next and the last divisibility rule that we're going to talk about is for 3. How do I know if a number has 3 as a factor? Okay, I'm actually just going to write out here the 3 times tables quickly. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, on and on and on. Okay. So the divisibility rule for 3 is a little weird, but we're just gonna trust it, okay? As opposed to understand exactly why it works. For 3, what you're gonna do is you add up the digits of the number, and then if the sum of those digits is divisible by 3, meaning if when I add these digits up, if it's a 3 times table, then that means this also is a 3 times table, and then it has 3 as a factor. So I can divide it by 3. So let's look here. When I add up the digits of 123, 1 plus 2 is 3, 3 plus 3 is 6. Because 6 is divisible by 3, I know that this 123 also has to be divisible by 3. Okay, and then for 432, 3 plus 2 is 5, 5 plus 4 is 9. 9 is divisible by 3, right? It's a 3 times table. So this must also be divisible by 3. So let's go from there. Let's divide by 3. Again, I'm going to have to do some long division. Maybe. I could do it in my head, but let's go ahead and do some long division now. Can 3 go into 1? No. Can it go into 12? 4 times. Nothing left over. Bring down the 3. 41. Okay, so this becomes a 41. And then 432 divided by 3. 3 goes into 4 once. 4 times. Gives me 1 left over. Bring down the 2. And 4 times 144. Here we go. That is our reduced fraction. We actually can't go any further than that. So let's take a look at one last example. And it's going to bring together a few of our divisibility rules here. Okay, so here we have 630 over 945. And we've been asked to simplify or reduce this fraction. So I don't know the times tables up to here. We got to rely on divisibility rules. Let's check our divisibility rules and see which of these might apply to both, right? Oh, this ends in 0, so it's divisible by 10. Is this also divisible by 10? No. This ends in 0, so it's also divisible by 2, but is this? No. What about 5? Yep, this ends in 0 and this ends in 5, so they both meet the criteria for 5, right? So they're both divisible by 5. So what we're going to do is we're going to go ahead and divide by 5. Divide by 5. More long division. Okay, 5 goes into 6 one time. 1 left over. 13. 2 times. 3 left over. 6 times. So this is 126. Okay, and then 945. Divided by 5. 5 goes into 9 one time. 4 left over. Bring down the 4. Goes in 8 times. 4 left over. Bring down the 5. Goes in 9 times. Okay, so 189. Okay. Now I look and I still feel kind of stuck. I know my times tables really well. These are not on the times table chart. So let's look at our divisibility rules again. The one that's going to work for us is the 3's. Do you see that? 1 plus 2 gives me 3, plus 6 gives me 9. 9 is divisible by 3, right? So I know 126 must be divisible by 3. And for 189, it's the same. 1 plus 8 is 9. 9 plus 9 is 18. That's also one of my 3 times tables, which means it's divisible by 3 as well. So we got to do more division. Divide by 3. Divide by 3. But let's go ahead and do a little mental math here, okay? Well, I know 12 divided by 3 is 40. 12 divided by 3 is 4. So 120 divided by 3 is 40. And then there's 6 more, which is 2 more 3's, so total 42. And then here, 3 times 6 gives me 18. So 3 times 60 would get me to 180. And then 3 times 3 gets me 9, so 63. Okay? Now, finally, I've reduced it enough that I can use my times table knowledge. These are both 7 times tables. Divide by 7, divided by 7. And then we actually can go even further. 6 and 9 are both 3 times tables. So we divide by 3 and we get 2/3. Okay? All right. So we've covered how to find equivalent fractions, how to reduce fractions. And as always, thank you for watching, and I'll see you in the next video.